Russell from the release team, he has a quote, and he says he's able to use commodity hardware to achieve the same functionality as a traditional storage array at a far lower cost. Click. Another case study is a parallel data warehousing SQL appliance that Microsoft develops. By running Spaces, they got a 2x reduction in the hardware acquisition costs, 2x increase in the storage throughput, tripling of their data density, and a 5x reduction in complex query execution time, which is very important metrics for this team because customers use this metric to compare different parallel data warehousing appliance solutions. Paul Dyke, from a principal architect from PDW, says that Spaces is a key foundation of SQL PDW. It enables them to vastly improve their performance and is a game changer for their architecture. Now we have another deployment approach. It's the performance optimized approach. There are many customers out there that their workload simply demands an extreme level of performance, perhaps in the level of millions of IOPS. And Spaces absolutely scales to that level. Last year at TechEd, we showed a deployment where we had 3 high-performance server nodes. These are clustered server nodes connected to a 24-bay JBOD, 2U 24-bay JBOD. We filled that JBOD full of SSDs, and we presented storage up to those 3 nodes. In aggregate, through this 3-node cluster, through these 24 SSDs, we're able to achieve 1.45 million IOPS and 12 gigabytes a second of sequential throughput. Out of 8U. 8U worth of gear was able to do this. 8U worth of commodity gear, might I add. We actually have after this was shown in last year's TechEd. After this, we got another test deployment from vendors, and we got 2 JBODs. Same 3 nodes, 2 JBODs. We pushed 2.7 million IOPS, adding another JBOD. So I have a performance-optimized approach, I have a capacity-optimized approach. But now how do I build a deployment if I have these 2 goals? I want 16 terabytes of capacity. I want 180,000 IOPS. How do I do this? Well, I can try it with hard disk drives. I'd easily meet my capacity with 6 drives, but I'd miss my IOPS goal by a huge margin, simply because these drives are not optimized for random access. They're optimized for sequential access. They're optimized for high capacity, low cost. I could try SSDs. I'd meet my IOPS goal with only 4 of them, because SSDs are real fast, but I'd miss my capacity goals by a huge margin as well. I mean, I could, again, deploy more SSDs, but that would become cost prohibitive. So again, there must be a balanced approach. Mix of HDDs, high capacity, mix of SSDs, high performance, delivering the best balance between dollars per terabyte and IOPS per dollar. With 6 HDDs and 4 SSDs, I meet both goals at a dramatically lower price than attempting to meet the goals with SSDs. Let's talk a little bit about storage spaces before we get into that. At the component level, Spaces uses fairly simple hardware. You can look at some of this hardware shown on the screen here. Let's look at one of these big boxes here. This is a 60-bay JBOD. It's a 4U 60-bay JBOD. What comprises it? Well, obviously, there's sheet metal. There's a SAS backplane, which I plug in my dual-port enterprise-grade SAS disks into. There's redundant power supplies to ensure I have resiliency against power failure. There's redundant SAS controllers to ensure I have resiliency against path failure. So these are enterprise-grade components. And on the screen here, we have a sampling of some of the available Spaces certified hardware on the market today. We have hardware from RAID Incorporated, Data On Storage, and Fujitsu. Data On Storage actually has a booth here on the TechEd floor, and they'd be more than happy to show you some of the hardware they have on display. But the point is, this hardware is commodity hardware. It's simple and it's cost-effective. But it handles your enterprise workloads and it handles your enterprise resiliency needs. So starting from 2 24-bay JBODs, so that's 48 disks in these 2 JBODs here, I'm going to show you what Spaces is. I don't manage those physical disks. I don't manage those disks one by one. I don't have to create RAID groups. I create a storage pool. And this storage pool aggregates all of those physical disks, all of those 48 disks. I manage that storage pool. I don't manage individual disks. From that storage pool, I request spaces to give me some resilient storage spaces, also known as virtual disks, with different characteristics, different resiliency characteristics. I can have mirrored spaces, keeping 2 or 3 copies of my data, or can I have parity spaces, also keeping 2 or 3 copies of my data. And these disks, even though they're abstract concepts, they appear in Windows just as regular disks. So your workload runs on them just as any other disk would. Spaces utilizes native data striping to ensure that I/O requests, read and writes, are distributed amongst multiple spindles at once, ensuring that a data request can be serviced much quicker than it could by an individual physical disk. We spread your data around all the disks in the pool to ensure you have the maximum performance and maximum resiliency. With Spaces certified hardware, you get the benefit of enclosure awareness. What this means is that if I'm creating a resilient storage space, a mirror or a parity space, we're going to attempt to put your data, place your independent copies of data on independent JBODs to ensure that if one of those JBODs were to completely fail, there's still another copy of your data available. We have a service that runs in the background for NTFS and REFS volumes, and that's called the Data Integrity Scanner. Some of you might know this as a scrubber. What this does is it ensures your data is protected against latent corruptions, because Spaces provides an API that you can expose the multiple data copies up to an application. Data Integrity Scanner goes through, scans the data copies, ensures that the copies are consistent. With Windows clustering, Spaces provides continuous availability, and I'll talk about clustering in just a moment. What if one of those disks were to fail? What if a disk failed in my pool? How does Spaces handle that? Remember when I talked about how Spaces spreads around your data? It's because we spread around the data, we're able to recover quickly from this instance of the disk failure. When a disk fails, we can logically rebuild the data that was logically, quote unquote, on that disk from multiple disks simultaneously. We parallelize the rebuild process. So we're not bound by an individual point of rebuild, such as with a hot spare. With R2, we actually have done internal testing. We have an 8 3-terabyte disk testbed. We simulate the failure of one of those disks, so that's 2.4 terabytes of data to rebuild. We're able to rebuild that failed disk in 50 minutes at a throughput of 800 megabytes per second. 800 megabytes per second, way beyond what an individual disk can do. And this is what parallelized rebuild can do. This is what the capability of spreading around your data can do to ensure that you have multiple copies placed on different disks so that when you rebuild your disk, you can rebuild onto multiple spindles at once. Let's build up the cluster from the ground up. So we have 4 60-bay JBODs, 4 of these 60-bay JBODs. So that's a total of 240 hard disk drives. I connect these in a resilient manner to 4 clustered file server nodes. And what that means is that each node actually has 2 connections to each JBOD. So there's 8 cables coming out of each node. And that entire infrastructure through SAS has 768 gigabits per second of raw throughput. 768 gigabits per second from all my file server nodes to my JBODs. In the event of one of these nodes were to fail, because another node sees the exact same storage, it just takes over. It fails over. This is high availability. From these physical disks in the JBODs, and from these physical disks into JBOD, I create a storage pool. This is my aggregation of all these physical disks. And from the storage pool, I carve out my resilient spaces, my mirror spaces, and my parity spaces. But because I have multiple virtual disks, and multiple servers, I need an easy way to manage my storage. I don't want to have to go to each individual node to find out what storage is on it. That doesn't scale. CSV, on top of this, now provides a unified namespace for data access. Even though I have multiple virtual disks, multiple nodes, I have one flat namespace. I go whack, whack cluster, and I see all my storage in one location. And I simply share out shares from my CSV out to my Hyper-V compute nodes for my workload to run on it. And what this unified namespace enables is easy VM migration. Because it only talks to one point, only talks to one namespace, I can easily move my VMs around. Because my VMs are talking to a share, and that share has the same name, no problem. Also because the storage moves with the VMs. You can scale out even more. I can add more servers, I can add more JBODs, I can add more virtual disks. And my CSV scales linearly as I add all these components together. Flat namespace, Hyper-V compute nodes continue to access the same namespace, VM migrations work. In this example here, we have close to 1 petabyte elements of 4 file servers and 4 60-bay JBOD arrays. That's close to 4 petabytes and a rack and a half of gear. Close to 4 petabytes. So, by the way, if anyone has any questions or any clarifying points, please feel free to raise your hand. I'll be happy to take a few questions. Oh, yes, sir.
So you said it scale. So let's say you want to have 8 servers. So
Yes.
previously you said each server had 8 connections
Yes.
to the JBoss, right?
Yep.
So what would have happened if you now have 8 of those? Would they have 16 connections on the back of each server, or how would it work?
So the gentleman's asking if I had 8 servers instead of the 4 servers, would I then have 16 connections to the JBods? So based on what hardware is available in the market today, those 60-bay JBods have 2 SAS controllers. Each SAS controller has 4 ports. So one of those 60-bay JBods can connect up to 4 nodes. If I wanted to connect more nodes to increase my compute capability, I would simply add another unit. It makes sense in many workloads to simply add another unit because I would need the additional compute anyways to go along with that storage. So this node can continue to access data on this node because I can access it through the CSV. So any node on the cluster can access any other nodes on the cluster's data through the CSV. And I/O simply gets redirected through the cluster network, which is, yes, through the cluster network, I/O gets redirected. It's a great question. Now let's show you how we can deploy with exceptional IOPS per dollar. So we talked about capacity optimized, we talked about performance optimized. Now let's talk about the balanced approach. When looking at many common enterprise workloads, we see that we have a large data set, a very large data set, but a majority of the data is potentially cold. It's not accessed very frequently. And we see that we have a minority of the data that is in active use and is hot. This hot data is what we call the working set. And of course, with any workload, working set changes over time. We also see we have 2 common types of drives in the market. We have hard disk drives, rotating drives, and we have solid state drives. Hard disk drives, you're looking at 7,200 RPM drives. They go up to 4 terabytes of capacity today. That's a huge amount of capacity. They're capacity optimized, and by deploying these drives, I reduce my dollars per terabyte. And they're low cost. And because these drives are such large capacity, and because my workload has such a large data set and a lot of it's cold, it seems natural to match these up. On the other hand, we have solid state drives, which are performance optimized, and by deploying these, I improve my IOPS per dollar. And we also see a very similar mirroring. We see that a minority of data is cold, minority of my data is active use and is hot, and that's my working set. I have a small amount of working set, and my solid state drives are small. It seems natural to add solid state drives. But of course, there needs to be a way to seamlessly integrate my high-capacity hard disks, my high-performance solid-state drives. And that's exactly what we're doing in R2. Tiered storage spaces in a single virtual disk utilize the best characteristics of rotating media, high capacity, low cost, storing my larger, cold data set, utilizing the best characteristics of SSDs, high performance, to store my most frequently accessed data, the working set, to deliver the best balance between capacity and performance. Now, with storage tiering, we actually integrate tiering into the file system. And by doing this, we get a number of cool things. In the background, as your workload's running, the file system will actively measure your workload's activity, how hot it is, which portions of your file are hot. And as your files get hotter, we'll automatically and transparently move those portions of files to the SSD tier. And as your data gets colder, we'll automatically and transparently move that data to the HDD tier. Because we integrate with the file system, we can do other neat tricks. When I delete a file from a tier, let's say the SSD tier, I can immediately free that space up for use by other hot files that are coming in. This enables me the most efficient utilization of the SSD tier. Tiering occurs daily. That is data movement and analysis. And you can configure this as a scheduled task. You can configure when you want it to run, configure how frequently you want it to run. And Scheduled Task Manager provides a very nice UI for this. Yes, sir? Yeah, so the gentleman is asking what is a good ratio? Do you have guidance on a good ratio between SSDs and HDDs? So by analyzing just cost performance ratios, we found that the best and likely most compelling ratio for most customers would be 4 to 8 SSDs to HDDs, or 4 to 12 SSDs to HDDs in a 60-bay JBOD. Now, that provides the best, in terms of math, it provides the best balance between dollars per terabyte and IOPS per dollar. But of course, in terms of your own workload, you would need to figure out what is the best ratio for your own needs to balance your budget and to balance what performance you really want. Does that help answer your question? Yeah. And of course, we're going to have documentation when we ship Windows to try and help customers figure out what's the best balance for the workloads and have a guidance on which workloads might suggest a certain way to calculate that balance. Yes, sir? So we are working with the Exchange team. They would need to announce their own support for tiered spaces and what the recommendations of deploying tiered spaces with Exchange.
So nothing at the moment?
Well, we don't have anything we can talk about at the moment. Okay. Yeah, we're still working on that information. We are testing a number of end-to-end workloads with tiering to ensure that we tune our algorithms to support those types of workloads and come up with the right set of guidance around provisioning, et cetera, and so forth. Yeah, but that would involve a lot of work with the Exchange team and their support staff. Yeah, yes, sir.
What block size are you moving up and down?
So we track heat based on 1 megabyte chunks of files, and we also perform the movement in those 1 megabyte chunks. We've tried to find a balance between not tracking too much information and also trying to move data in the largest possible chunk. Because at times, we're going to be moving data to the HDD tier, and we don't want to introduce too much randomization to those hard disk drives because they are optimized for more sequential large block access. Yep. Yes. Okay, so the lady's asking, is the data movement scheduled or is it automatic? The data movement and analysis is a scheduled task, and it occurs daily. You can configure the scheduled task to choose whatever time you want the data movement to occur, or you can disable the scheduled task to kick off movement and analysis whenever you see fit to match your workloads. You can do it more frequently once a day, absolutely. Yes. I'll take one more question before I move on. Yes, sir.
Will all writes go to the SSD tier first, or do you go to...
So actually, I have a slide couple down that talks very close, similar to that point. I'm just going to move on. We can finish off the questions in the next couple of slides or at the end. Because we integrate closely with the file system and we're closer to the workload, we're closer to the administrator, we provide the ability to override automatic placement based on heat. I can, as an administrator, utilize PowerShell to specify a specific file is to be placed on a tier, overriding the automatic placement. I can say that a file should be placed on the SSD tier. I can say a file should be placed on the HDD tier. You can imagine a great use for this would be in a pooled VM scenario where a single parent services thousands of VMs. By pinning this, by assigning this file to that SSD tier, I just improve boot times for those thousands of VMs. And I guaranteed the service times of that file as well. And this is only possible with the integration of the file system. Tiering provides several forms of administrative insight to figure out how my tiered implementation is working, and do I have enough SSDs to service my working set. So we actually have a sort of chart, which is an analysis report that prints out after you run the optimization. And it tells you how much of your working set, or how much of your most frequently accessed data, is contained within the SSDs. And if I were to add a certain amount of SSDs, how much more of my active data would be contained? What are the benefits of adding more SSDs? And of course, you can continue to utilize performance counters to determine how your workload's performing in terms of response times and in terms of throughput and transactions per second. Another capability to improve IOPS per dollar is called the write-back cache. This is a persistent write-back cache which utilizes available SSDs in the storage pool. It's a per virtual disk write-back cache. It utilizes available SSDs in the storage pool to smooth out short-term bursts of random write activity to my virtual disks. Tiering balances capacity and performance. Write-back cache smooths out short-term bursts of random writes. And the write-back cache integrates seamlessly into a tiered volume, and it's enabled by default. But you can enable write-back cache on non-tiered volumes as well. And to answer a gentleman's question before, when you get writes and they're of a sufficient, they're of a certain random size, then they're of a certain size, then they will be serviced by the write-back cache first, which is on SSDs. Larger, more sequential writes are serviced by the hard disk tier. Yeah. So this is mostly for smaller writes. Let's show you a demo of how to build a tiered storage deployment. So I don't know how many of you are familiar with Storage Spaces PowerShell, but I've tried to make this as easy as possible and assumes and goes through the full gamut of steps to build up my Storage Spaces deployment. So first part of a Storage Spaces deployment is to get the physical disks that are available on the system. So I'm going to go do that. So you can see on the system, I have 8 physical disks. Someone's battery is dead. So you can see on the system, I have 8 physical disks. But only 6 of them I can utilize for storage spaces. That's disks 1 through 6. I have 2 disks that are 200 gigabytes in size, and I have 4 that are 1 terabyte in size. So I'm going to go ahead and grab those disks and put them in my $disks variable. Utilizing these disks in $disk, I'm going to then create a storage pool. I pass in my Spaces storage provider name. I pass in the friendly name of my storage pool. And I create a new storage pool. So it's now going and writing out all the metadata onto these physical disks. Spaces is unique in that each physical disk has a view of all the other physical disks in the pool. So if I was to take a physical disk from one deployment, take that one individual disk onto another system without a view of all the other disks, this disk would realize, hey, where's all my buddies? He knows about all the other physical disks in the pool. So now I have my disks in the pool, let's take a look at what kind of disks I have. I'm going to look at the media type. Now, we've added this media type in R2 to support tiering. Windows will automatically detect if your disk is an SSD or as an HDD and assign the appropriate media type. Or you can override the media type of a physical disk to be SSD or HDD, as long as you have not allocated anything on that physical disk. So if, for instance, if we do not detect the media type or it's undefined, you can specify that media type as SSD. So you can see I have 2 SSDs and 4 HDDs. I'm going to now create my pool level storage tiers. I'm going to create my SSD pool tier, and I'm going to create my HDD pool tier. These are new commandlets also introduced in R2, new dash storage tier. Now that I have my pool tiers, I've created my pool, and I've ensured that my physical disks have the right settings applied to them. I'm going to create a new virtual disk, a new tiered virtual disk. The process to do this, I apologize if the font's kind of small, but I have all the notes in my slides in the appendix, so be sure to take a look at that at the end of this session. But you pass in the storage tiers that you just created. So I assigned SSD tier and HDD tier as variables. I pass those into the storage tier parameter. And I also pass in the size I want. So I want 150 gigabyte SSD tier, and I want a 1.75 terabyte HDD tier. I want a mirrored storage space, and I want to create a virtual disk with a 5 gigabyte write cache. Now what this command is going to do is then it's going to take 5 gigabytes of capacity and 150 gigabytes of capacity from the SSDs in my pool and create a virtual disk with them. So I'm going to go ahead and do that. So it's created a virtual disk. You can see it's approximately just over 2 terabytes in size, and it's healthy. Well, we should be healthy. So I'm going to now format that disk, create a partition, create a volume, assign it a drive letter. Do this all in the background. You don't have to see this. I'm going to copy in some test files. So I have 2 files, archive1 and marketing pool VM parent. And these are all both on the E drive. I'm going to now pin the parent file to the SSD tier. And this commandlet, set-file storage tier, I pass in the file path. I pass in the desired storage tier, which I get from the virtual disk that I just created. And it will go ahead and process the request. Okay? So I now also want to pin my archive to the HDD tier. I do that in a very similar way. I now get the list of assigned files, the tiers, and the status with get file storage tier, passing in the volume drive letter. You can see that my archive1.vhdx, the placement status is not on tier. And there's the file size on desired storage tier 0. So you can see that none of this file is on the HDD tier that I want it to be on. But the marketing pool VM parent just happened to be on the right tier. But in order to move that archive1 to the right tier, I need to immediately trigger the data movement. Now, typically, data movement would occur whenever the scheduled task kicks it off. But if I want that's done right away, I can issue a command to have it done immediately. And that is optimize volume. We've added a flag tier optimize to initiate the data movement. So I'm going to initiate that now. It's going to take a few moments to process and analyze. Okay, it's done. Now let's get the updated status. You can see the file that I have pinned on the HDD tier is now completely on the tier. Both the files are completely on the tier. So I just walked through the process of creating a pool, looking at what the media type of my physical disks were, creating pool storage tiers, and creating a tiered virtual disk, and pinning the files, and kicking off immediate data movement. All these commands are available in the appendix of my presentation. Yes, sir? So the question was, what type of volume config on there? Is there data deduplication enabled? In this demo, I've just created the most basic configuration possible. Just created volume, formatted it with NTFS, and assigned it a drive layer. However, I could enable dedupe on this volume, no problem. And there are PowerShell commandlets to do that. Yes? Yes, storage, the question is, can I use REFS? And the answer is storage tiering supports both NTFS and REFS. Yes. Okay, let's switch over to my second demo. Remember what I told you that the write-back cache absorbs short-term bursts of random write activity to your virtual disks? Now let's show you how it does this. I have two perfmon windows on the screen here. One of them is showing perf counters, the left one, or the right one, sorry, is showing perf counters on the virtual disk without a write-back cache. The left one is showing perf counters on a virtual disk with a write-back cache. You can see the blue line indicates that I'm doing a workload to both virtual disks. This workload is doing approximately 550 IOs per second. This is a workload I really care about, and I don't want affected by any other workloads. Superimposed with this workload is a dotted red line. You might not see it right now, but that dotted red line indicates the total IOs per second occurring to that volume from this blue line workload and any other workload that I would introduce. Write-back cache absorbs short-term IO spikes. Let's introduce those short-term IO spikes. I just introduced a random IO spike to both volumes. You can see the dotted red line on both graphs went up, indicating more work was done by both volumes, the blue line workload and my random write spike. However, the volume without a write-back cache, my blue line workload dropped as a result of this write spike. But the volume with the write-back cache, there was no impact. Let's give it a couple more. Again, write-back cache absorbed that write spike. Let's give it another one. Seems like write-back cache is doing its job. Let's continue to my next demo. What I'm going to show you is the seamless transition of a file from the HDD tier to the SSD tier of a tiered volume while an intensive I/O workload, and when I mean intensive I/O workload, is occurring to that file. Another perfmon window. You can see I'm doing an intensive workload to the file, and it's delivering me about 2,600 IOs per second. This file is completely located on the SSD tier, and this is the IOPS we would expect from that tier. So I'm going to now kick that file on over to the SSD tier and immediately start the process of data movement. Right now, this started off on the hard disk tier, the tier with rotating media, and it's being kicked up to the SSD tier while an intensive I/O workload is happening. You can see the file system right now is moving the blocks that underlie the file underneath the workload. It is not affecting the performance of the workload. And as more and more blocks get moved to the SSD tier, because my workload is random across the entire file, it's going to start being serviced from the SSD tier. And it just shot up. Now that all of the blocks are serviced from the SSD tier, the movement was done. This process from the HDD tier to the SSD tier was seamless, with minimal or very close to no impact to the performance of my intensive I/O workload. Little or no impact. Okay, went through both. Oh, yes, sir. So in this release, we have focused on delivering that high-capacity tier, high-capacity, low-cost tier, and that high-performance tier. Our architecture does not preclude the possibilities of more tiers in the future, but we only support those two types of tiers in this release. Yes, sir.
Do you support different disk sizes in the same tier?
So the question is, do we support different disk sizes in the same tier? We absolutely support that, and Spaces will distribute the IOs across to best utilize all those disks, all the capacity of those disks. And I can draw you a diagram afterwards how it does this if you want more information. gentleman in the back. Yes.
Pardon me if I missed this. When you add SSD tier to your spinning disk tier, is the amount of space presented the aggregate of the two, or is it just the size of the spin?
So the question is, if I add SSD tier to the HDD tier, is the size of the volume, or the entire virtual disk, an aggregate, or is it disk spinners? The size of the virtual disk is the aggregate of those tiers. Because Spaces constructs the virtual disk, puts the SSD tier, puts the HDD tier, and presents that as one logical namespace to the file system. The file system manages where all the files go, and we have a tiering engine which determines how it places hot data and how it places cold data. Yes, sir. So the question is there a minimum number of IOs for data to sit in the SSD tier? The way our algorithm works, just a very simple explanation of how our algorithm works, is it works on determining what data is active and how frequent it was active for. So there's no minimum number of IOs other than, of course, one. If my Absolutely. Absolutely. And unless that data gets colder, unless the activity of that data goes down, we wouldn't move it out of the tier unless something else got hotter. Yes. Oh, yes, sir.
You migrated, like, you did a manual migrate, moving that test file for your demo.
Yes.
If you did that, does that have a higher priority over data that's already in there? So if you look out other data?
So the question is, when I manually assign a file to a tier, does it get higher priority than placement based on heat? And the answer is yes. We believe that administrators would want to try and enforce their quote-unquote storage quality of service before that of automatic based on heat. Yes. Because actually a good scenario for that is a VHD file. If I want to pin a VHD file, in reality, if that file was apparent, not the entire file is, not the whole file is hot. So a portion of that file would be serviced out. But as an administrator, I just told the system that I wanted to pin this file. I wanted to ensure that service is from SSD tier. So in that case, we always would want to have the manual placement to be priority over automatic placement.
All right, so how about if we revise that? Is there a way to manually change the heat? So I don't want to pin it, but I just want to make it hotter than other heat.
The question is, can I manually change the heat? There is no mechanism to manually change the heat, but of course, as you accumulate more IOs, the heat would increase. Let's just get through a couple last slides, and I'll take the rest of the questions in a second. Microsoft partners with a number of solution partners to deliver certified cluster Spaces solutions. We have 3 partners here on the screen that currently provide these certified solutions. We have RAID Incorporated, Fujitsu, and DataOn. These partners provide high-performance servers, high-performance storage, but please be sure to visit their websites to find out more information on what product offerings they have. Again, we have a partner here on the TechEd show floor, and that is DataOn. They have a number of hardware on the floor that are interesting, so please be sure to visit their booth to see what they have to offer. Tiered storage utilizes the best characteristics of SSDs, best characteristics of HDDs, deliver best balance between high performance, high capacity. Delivers you the most cost-efficient storage. Windows Server 2012 R2 is a key component in your cloud. It delivers cost efficiency, delivers your scalable data access, it's continuously available, and it's operationally simple. I can manage my entire deployment from storage to Hyper-V through PowerShell and SCVMM. There's a number of other sessions that I would highly recommend you to attend. Unfortunately, some of those sessions have occurred already, but if you look at the deck, you can, of course, refer to the other sessions online. And after this session, if you have any more questions beyond that which is going to be answered here, please be sure to find me at the storage booth, me or another person. Thank you. I'll take questions now. Yes, sir. The question is, why did I choose 5 gigabytes for my PowerShell demo? Is there a recommended size? How do I choose the size of my write-back cache? So we are working on documentation to guide customers how to optimally choose their write-back cache. We would recommend a good balance between not having too large of a write-back cache, because in fact in a cluster failover, you would not want because we actually destage items from the write-back cache, you would not want to create a too large of a write-back cache. So we'd recommend right now up to a 10 gigabyte write-back cache, but you can of course adjust that to meet your workload. So utilizing perfmon, you can actually figure out how many random writes of a certain size you're getting. And you can figure out from that data how large you might want the write-back cache to be. So there are certain suggestions on how to figure out the write-back cache size. And one nice thing about Spaces is that you can actually configure the size of the write-back cache instead of having a fixed write-back cache size that you might have with many of the solutions today. Oh, yes?
If you have like a 15K drive, you also have 7,200 RPMs, would you ever have the 15K in the same queue as SSD in the current solution before you got to actually carry on?
So the question is, if I have 7.2K drives, 15K drives, and SSDs, could I put the 15K drives in the SSD tier? Is that the question? So if we actually look at what 15K drives offer in terms of performance, price, power, they're really not that interesting compared to SSDs. 15K drives consume about 5 times more power than 7.2K drives. They only offer up to 300 gigabytes of capacity versus 4 terabytes of capacity in 7.2K drives, and they're very expensive. From a point of view of deploying my own storage, I would want to have as much capacity as possible, as low cost as possible drives. There's my 7,200 RPM 4 terabyte drives, and the fastest possible drives. That's my SSDs. Rather than having a drive that's only 2 times faster at best than the 7.2K drive, I can have SSDs that are 20 times, 100 times faster potentially. So in terms of having that tier for mixing 15K drives and SSDs, it's not super compelling to most customers. Yeah, it's a good question. Yes?
So can you set up a storage space with data on those disks already, or do you want to create an empty storage space?
So the question is, can I set up a storage space on a drive with existing data? And the answer is no, but there is a caveat. If there is free capacity at the end of that drive, in other words, if I shrink my file system to be only maybe 50% of the drive, I can use that empty capacity at the end of the drive. However, we always recommend customers to utilize fresh drives so that space can consume as much space as possible, so that it enables us to properly distribute the writes around the disk to ensure optimal performance. Yeah. And also having a drive with part data, part space is not really easy to manage. It's best just to manage that one individual disk. If, for instance, that disk fails, I know exactly where that disk is going. Yeah.
What about using other storage aside from SAS on the back end, like a disk RAID if you already have one?
So the question is, can Spaces utilize existing traditional storage, such as Fibre Channel or iSCSI? We certainly would not. We don't recommend it, and we don't support it. And the reason is twofold. First of all, by utilizing an additional layer above Fibre Channel, you've added another layer of abstraction, and it's kind of hard to manage Spaces on top of Fibre Channel. And especially if errors start coming up from Fibre Channel, let's say that disk fails, you might not actually get the error up to the storage space. We haven't tested that configuration. And Spaces is fundamentally about reducing the cost of storage. By utilizing Fibre Channel or iSCSI, that implies something that you've already paid quite a lot of money for. It implies something that's expensive. If I use commodity JBODs on Spaces, that really delivers me the best cost, rather than utilizing a Fibre Channel solution. Yeah. Yes?
You showed some hardware vendors. What about the tier 1 vendors like IBM, Dell?
So we are always working with other vendors to ensure that they can produce Spaces certified solutions. we would encourage you to contact those vendors and express your own interest in those solutions to help get the ball rolling. But of course, we are working on it. We are working with many partners simultaneously to get more certified solutions out there. And the solutions provided by DataOn, RateInc, Fujitsu, these guys are always continuing to produce more products. So please feel free to contact all the vendors out there to determine what support they have for spaces and if they're thinking of anything in the future. Yes?
Can you lose more than one drive, or is it a percentage of drives that you can lose before it goes down?
So the question is, can I lose more than one drive, or is there a percentage of drives I lose before the pool or space goes down? So there's two answers to this. Spaces provides different resiliency types. I actually have a appendix slide on this. So Spaces provides different resiliency types. Provides mirroring and parity. These are basic resilient spaces. Mirror and parity can both provide resiliency against 1 or 2 disk failure, keeping 2 or 3 copies of your data. Now, if one disk fails in a mirror, of course, it won't be susceptible anymore. But if I have a 3-way mirror, then it would allow for another minimum of another disk failure. And it's the same thing with parity. The answer to the second part, as to percentage of drives failing, Spaces, much like a cluster today, has an idea of quorum. So I need to have a quorate pool. I need to have a certain percentage of my pool in unison in order for my space to be resilient. And that minimum percentage is 51%, just like in a cluster today. I need to ensure that I at least have enough nodes in my cluster to ensure I have a consistent view of the cluster. Yes?
So for a single drive inside of your storage spaces, you would set it for mirroring and parity. But if, say, you lost a drive that had part of the mirror,
Yes.
had time to replicate elsewhere, you could then lose that data again. So you could actually lose more than just you can only have, say, 2-way mirror, as long as they don't fail at the exact same time.
Can you repeat that? I didn't get the whole thing.
So what if the failures happen? Like, you've had a bad week, and so
Sure.
on Monday you lose a drive, and you got them the data migrated to the other disks. And
Yes.
then on Tuesday you lose a second drive. So even though you only got 2-way mirror, you'd still be fine, right? Because it's already.
So the question is, if I have successive drive failures, let's say I have a bad week. So this gentleman's clearly having a bad week. He has successive drive failures. How does Spaces handle it? So Spaces, whenever you lose a drive, it'll automatically attempt to rebuild that data in a parallelized manner, as I showed you guys before. It rebuilds to multiple spindles at once. And once that rebuild process is complete, it's again resilient to a failure of another drive, or perhaps potentially 2 drives in the case of a 3-way mirror. So once that space becomes healthy, and you can see the status in Server Manager, and you can see the status in PowerShell, once that space becomes healthy again, you're then resilient to another potential data loss. The question is the resiliency setting for my different tiers have to be the same? Is that the question? In R2, the resiliency settings for SSD tier and HDD tiers need to match. The resiliency setting and the column count need to match, but my capacities can be different, of course. Yes, column counts need to match. Yes, sir. The question is there support for hot spares? The answer is yes. We do have support for hot spares. We introduced that in 2012. However, because we do parallelized rebuild, we would actually not recommend the use of hot spares. Instead, just utilize spare pool capacity to rebuild the drives in a parallelized manner. Because if I'm using a hot spare, that is my single point of rebuild. I've just told Spaces I want everything to be rebuilt on this drive, versus rebuilt in a parallelized manner across all the available capacity in the pool. While you can use a hot spare, simply just use whatever pool capacity there is. Leave sufficient capacity on the pool to allow for rebuild to occur. Yes?
In your examples, you used an SMB file share and Hyper-V, I guess. Can you also use this with, say, iSCSI or NFS or other sharing?
So the question is, In my example, I use SMB as the way to share data to my Hyper-V nodes. And can I use iSCSI or NFS or any other means? The answer is absolutely yes. We provide in-box an iSCSI target for sharing my data out to iSCSI initiators. We provide, I'm not sure how much, I'm not sure what support we have for NFS, but we absolutely can use iSCSI. But of course, we recommend utilizing SMB because you get the great features of SMB 3.0. You get SMB Direct with RDMA, SMB multi-channel. You get all these great performance improvements by using SMB. Does that answer your question?
Yeah.
Yes. Yes, sir.
How does defrag fit in this picture? Is still something considered about in such volume?
Oh, sorry, can you repeat that? I didn't get the first part.
How does defragging the volume fit in this picture? Is this something still to be considered?
So the question is, does defrag fit in this picture? And what was the last part of the question? I didn't get you. Can you speak up just a little bit? Sorry. Maybe the speaker, yeah.
The question is, should we still defrag such NTFS volumes?
Oh, okay.
Or is this something we shouldn't worry about anymore?
Okay, so I think everyone probably heard the question. Should defrag continue? Should defrag continue to be used? So defrag, what its job is to make data contiguous again. In the case of many workloads, perhaps your data might become less contiguous. If you're finding that your data becomes less contiguous, then it would be necessary to run defrag. Defrag is useful for those scenarios, just to make your data more contiguously accessed. To improve, especially on the HDD tier, because HDDs are more optimized for sequential access. So defrag would improve the performance of data access, especially VHD files on those tiers. Yes?
Is VSS going to be tier aware so that it doesn't migrate everything up to SSD?
We are looking at that right now. Yeah. Yes.
Will management tools like management have to be able to alert on pool usage and tiers so that we can alert on, if we're running out of space on a storage space on a pool that's different than normal?
Yeah, I'm not sure what management packs take the notifications from, but we expose notifications all the way up PowerShell. We have interfaces, WMI interfaces that allow for exposure of all these events, and such as pool capacity, running out of capacity, or capacity exhaustion, et cetera. So if those power packs they use these notifications, then yes, absolutely they would have it. But again, I'm not as familiar with power packs. Yes.
So if you're not using a hot spare, you're just using available storage for fills, can you specify guaranteed space available? Like, can you reserve a couple drives worth of space to be unused in case of failure?
So the question is, because we rebuild in a parallelized manner, we're utilizing spare pool capacity, can we reserve drives worth of space in the pool? And the answer is no, you cannot make that reservation. The only reservation is, of course, by creating a virtual disk, but then that would not make capacity available for rebuild. So just when you create your virtual disk, make sure you don't utilize, make sure you keep a little bit of capacity available in the pool. Yes.
I have a file on the SSD tier, and I run out of space in the SSD tier as I try to write to it.
Yes.
Will it fail, or will it move to the...
So the question is, if I have a file on the SSD tier and I run out of space on the SSD tier, let's say we're doing an extending write to that file, that write would not fail. NTFS or REFS would simply take allocation from wherever spot they can. Actually, interestingly enough, on REFS, because REFS, if I enable integrity stream, I don't know how familiar the audience is with REFS, but REFS has the ability to utilize integrity streams where it uses checksums to ensure the integrity of the data. Also, this integrity stream mechanism has a way of when I do an update of my data, instead of updating in place, it finds a new place for that block. It finds a new allocation for that block. And this avoids classes of corruptions that occur in update in place file systems. So uniquely with tiering, If a block is hot on REFS and it has integrity streams enabled, when I update this block and it moves it to a new place, it will attempt for that new place to be on the same tier. And this is only possible because we've done this in the file system. The heat moves with the data. Did you have a question? Oh, gentleman in the back.
When it's time to grow the pool, you add new spindles or you spread the strike back around?
The question is, when it's time to grow the pool and I add new rotating media drives, do we spread the I/O around? And the answer is absolutely. Any new I/Os, new writes that go to that virtual disk, will be automatically spread over to my new physical disks. We do not transition the existing data to those new disks, but instead the new writes would be distributed amongst the old disks and the new disks. Yep. Yep. Yes, sir. Can you clarify the? So the question is, can you go through the scenarios where write-back cache will be destaged? One of the scenarios is, of course, when the write-back cache hits the internal thresholds we have for starting to destage. Another case is where a system has recovered from an unexpected failover or has recovered from an unexpected power loss event. Spaces has a mechanism which is called dirty region tracking, which tracks any updates to my metadata, any updates to my pool metadata or space metadata. And in the events of a power failure, we're able to recover from events without a need of a battery backup with this. And one scenario of write-back cache needing to become in consistent state with whatever is in the dirty region table is in a power failure event or on an unplanned failover. Or, of course, when the write-back cache is approaching the thresholds. Destage is taking the data that's in the SSDs and then moving it to the HDDs. It's not a flush and say that there's anything that's not persistent. It's all persistent. It's just moved from SSD to HDD. Yeah. Yeah. Yes, sir, at the very back there. The question is PDW using this in concept, and PDW is absolutely using this in production environments today. So PDW may not be using Spaces certified hardware, so they don't get that enclosure awareness. What we would, of course, recommend to any customer out there to use Spaces certified hardware to get that enclosure awareness for their systems. Yes. Yes, sir. Red shirt. The question is, should hard drive caches be turned off? And the answer is, really, it depends on what your business needs are. Do you need maximum data integrity? Do you need resiliency against power loss without the need for UPS? Or do you need higher performance? In the case of higher performance, we recommend turning the drive cache on. But if you really want resiliency against power failures, you probably want to turn the drive caches off. Yeah. And actually, in a clustered scenario, all writes are done as write-through, which bypass the drive cache. So either drive cache on or off. In a cluster with continuously available cluster, every write is a write-through anyways. Yeah.
For drive failure, you do both predictive and hard failures, right?
The question is, for drive failures, do we do predictive and hard failures? We do have a certain level of predictive failures. We also have a PowerShell, PowerShell module. I believe they're called, right? PowerShell modules. It's available on, I'll find a link for you. And this PowerShell module goes through your disks